Hello everyone. So in this video, we're going to be talking about neutralization reactions, and eventually these types of reactions will help us understand a process called titration, but we won't get to titrations until a different video. So a neutralization reaction is what happens when you react an acid with a base. So for the acids and bases that we're going to be talking about, when you react them with each other, they are going to produce water and a salt. So we're just going to write out what the reaction looks like. It's reacting an acid and a base produces water and a salt. So when I say salt, you're probably thinking of sodium chloride, which is table salt, but actually any ionic compound is technically a salt. So when you react an acid and a base, and I'll give you an example with actual symbols here. So if we react hydrochloric acid with sodium hydroxide, the H from the acid will combine with the OH from the base to produce water, H2O. And the other parts of the compound, so the chloride ion here and the sodium ion here, will combine to form the ionic compound sodium chloride, which is a salt. But if this were a different ionic compound, we'd still call it a salt. Like it could be sodium iodide or sodium sulfide or any other ionic compound. So we'll come back to indicators in just a second. Let's do an example where we are predicting the products of a neutralization reaction between an acid and a base. So first, it's helpful to be able to figure out which of these is the acid and which of these is the base. So for the types of reactions we're going to be doing, if the substance ends in OH, OH is hydroxide, so it's going to be the base. And then if it starts with H is hydrogen ion, so it's going to be the acid. So to predict the products, let's write out the acid and the base. So we've got HBr plus KOH. And then we just need to remember that the H from the acid and the OH from the base are going to combine to form water. So I'm just going to cross them out because I'm using them to make H2O. And then the other two ions that are left, we need to look up their charges really quickly. So K is potassium. When K becomes an ion, it has a charge of +1. So I'm just going to write that down here. Bromide is a halogen. It will have a charge of -1 as an ion. So I just need to combine these ions and make sure that the charges cancel. It's pretty easy in this one since both are 1s. And then we always write the positive one first. So it will be KBr. All right, now if this was like a +2, then I would need 2 bromides. So in that case, it would be like KBr2. And there will be some situations like that, but this is a pretty simple example. Now let's go back up. We're gonna switch gears a little bit and talk about something called an indicator. So in a neutralization reaction, you might add an indicator to the reaction. And an indicator is a chemical that changes colors depending on the pH. So you might add an indicator to a neutralization reaction as you're adding, say, the acid to the base to be able to figure out when the base is fully neutralized because the color will change. So with indicators, you'll often see tables like this one. So this lists a lot of different indicators. These are indicators that would be synthesized in a lab. There are also natural indicators. In fact, a lot of flowers, fruits, and vegetables have indicators in them, especially fruits and vegetables that are like purple or red. So things like red cabbage, beets, blackberries, blueberries. These all have chemicals called anthocyanins that naturally are indicators. So if you boil some water and add some red cabbage and maybe even blend it up, you will end up with an indicator that will turn pink in acidic solutions and green or blue or purple in basic solutions, depending on the pH. So I just wanted you to realize that there are some pretty synthetic indicators, like these ones. There are also some natural indicators. Now, all of these are different in the way they change color. This shows the pH range at which they change color. So let's look at, for example, bromophenol blue. This indicator is yellow if the pH is below 2.8, and it is blue if the pH is above 4.6. So these two colors are telling you what color this indicator is in its lower range and what indicator it is, or what color it is in its higher range. And then right here, we see the range at which it's going to change colors. So here's an example of a question you might be asked. It says, use the table below to determine the color a solution with a pH of 5.5 will turn if methyl orange is added. So we need to find methyl orange. It's right here. And then it's asking, okay, what would the solution turn if it has a pH of 5.5? So we look and we see, okay, methyl orange changes from red to yellow between 3.2 and 4.4. So 5.5 is above 4.4, so that means the solution would be yellow at that point. So the answer would be yellow. So that is how you can use your knowledge of indicators to predict the color a solution will change.